Welcome everybody to this GCSE geography video covering tectonic hazards. We're going to be looking at the physical processes today that form earthquakes and volcanoes. We basically want to answer the question, why do earthquakes and volcanoes happen at a certain point? That's the goal. There's the specification if you want to have a look for AQA, and let's get into it. So we're going to start by looking at what are tectonic plates. So here's a diagram of, well, what's underneath our feet. So we've got the crust, very thin, what we stand on the mantle, and what you don't need to worry about the core. What you need to know about the mantle is it gets less viscous with depth, and what we mean by that is it gets more runny. So the top part is solid, and then it becomes more liquid until it's very runny. It's also hotter down here than it is up here. And what we call the crust and the solid part of the mantle together form the lithosphere. And the lithosphere is divided into things that we call tectonic plates. It's separated by a series of fault lines. Think of tectonic plates as puzzle pieces, and it sits, as you can see on this diagram on the right, on the asthenosphere, which is kind of a semi-molten bit of rock. You just need to be aware of that. It doesn't really matter. You should also be aware that there's two types of lithosphere, two types of plates or crust. Continental crust is older, thicker, it's less dense than oceanic crust, which is the main one we're going to be looking at in this video. It gets regularly recycled and it's much more dense. Dense is quite an important word in this video, especially in deciding how tectonic plates move. So scientists aren't really sure, but they've come up with a theory called ridge push slab pull, which is one of the most currently accepted theories. So the idea is that when magma comes up and cools, it forms a ridge, a divergent or constructive plate boundary. That's what we call them. We'll look at it later in the video. Gravity pushes on that. It compacts the newly formed rock, pushes it outwards, pushes the plate outwards and makes it more dense. So that's ridge push, and then slab pull occurs down here, where the plate subducts into the mantle. Subducts essentially means that one plate is going under the other. That's a technical geography word that you should try and include in your answers where you can. You know, the gravitational force of this heavy, dense plate moving downwards kind of pulls the rest of the plate along, and that is allegedly how scientists believe that tectonic plates move. So let's start looking at plate margins or plate boundaries. So constructive or divergent plate margins, obviously I've mentioned what happens. The two plates are moving apart, so we get shield volcanoes and small earthquakes. So earthquakes occur when the plates are moving apart. They can sometimes fracture, and this is a key term. It kind of just means to crack or break. So as they are pushed apart, they can sometimes crack or break. But shield volcanoes are the main tectonic feature here. So magma rises up, kind of spreads out due to its low viscosity. This is an important word. It means it's very viscosity is thickness, so low thickness is very runny. So it spreads out, forms kind of these layers as more erupts, forms this shield shape, and it's frequent because the vent doesn't get blocked because the lava spreads out, so it never solidifies and blocks the vent. And this is also why they're gentle and pose low hazard risk. Destructive plate boundaries or convergent plate boundaries or margins, you know, there's many different types, but you only need to worry about what you need to see in the diagram. We get a dense oceanic plate and a continental plate moving towards each other, and what happens is, because the oceanic plate is denser, it gets pushed under, it subducts under the continental plate, creating composite volcanoes and earthquakes. So we get earthquakes because as one plate moves under the other, you know, they can't move freely because they're jagged rock faces. There's a lot of friction, and this friction is to such an extent where it prevents them from moving, but they're still being pushed kind of by ridge push slab pull. So this causes pressure to build as they're trying to get past each other, and eventually one of the plates will fracture, allowing an erratic burst of movement, releasing a lot of energy, and this energy causes an earthquake, and that's what we feel as an earthquake. How do we get composite volcanoes? Well, when the plate is subducting, it melts, and this creates some very hot magma, along with potentially some steam from the ocean and some of the material. This is all very hot under a lot of pressure, and it forces its way up through the crust and erupts at the surface. The magma is very viscous because it contains a lot of plate material, so it doesn't move far, creating these steep-sided, cone-shaped volcanoes that we call composite volcanoes. The vent gets blocked after eruptions because the magma doesn't move very far, and therefore the magma gets stuck in the vent, and eventually pressure builds and explodes out, creating a violent eruption with kind of the tephra, pyroclastic flow, all the hazards that you associate with volcanoes. We don't look at them at GCSE in this course, but maybe A-level, really depends on what kind of course that you do. So the easiest plate margin to learn is conservative plate margins, or transform, as they're also called. And what happens here is they're moving alongside each other, either in the same direction or in opposite directions. And this creates earthquakes, but not volcanoes, as there's no gap for magma to come out of the mantle. There's no plate being created, no plate being destroyed. So with earthquakes, I've labelled on two keywords: the focus, the point where the rock fractures, and the epicenter, the point on the surface directly above where the rock fractures. Again, we get earthquakes due to friction, same way as destructive plate boundaries. The jagged rock faces can't slide past each other easily. Friction builds, pressure builds because they're trying to push past each other, but they can't. And eventually, one plate will fracture, so crack or break. And this releases energy that creates a strong earthquake. So that's your plates, that's how and why they form. Now, where do earthquakes and volcanoes, where are they found? Well, they're found along plate boundaries in narrow bands. We have the Pacific Ring of Fire mentioned here. Around the Pacific Plate, as you can see, there's lots of convergent or destructive plate boundary and lots of subduction going on, and therefore forming these volcanoes. We'll look at a map here. I've got a nice map. So this is a map, I believe, of earthquakes and volcanoes in the past 48 hours. There's a key over here, so magnitude of earthquakes and kind of amount of volcanic activity. In the last 48 hours since I've recorded this, there's been quite a few earthquakes and volcanoes. As you can see, Pacific Ring of Fire being very active over here, lots of destructive plate. And over here, Central America, lots of earthquakes as well. As you can see, some earthquakes around here where we get continental plates, not necessarily any magma coming up here, but still earthquakes happening. What I would like to draw your attention to is Hawaii, because you can see there's no plate boundary anywhere near it. So how do volcanoes form here, and how has Hawaii formed as an island? Hawaii is over a hotspot, and we call it a hotspot because in the mantle there's superheated magma which kind of rises up, forces its way through the crust and erupts out on the surface, forms a shield volcano, and it kind of creates this island chain because as the plate moves, a different area of the plate's over the hotspot. So the older volcano is no longer over the hotspot, becomes extinct, a new volcano forms, and this forms an island chain which will grow over millions of years. You can have a look at the other link, focuses on earthquakes and provides a bit more detail. It's very interesting, so go and have a look. I might put those in the description. But now we've covered all the content, so let's see what you can remember with an exam question. This is from the November 2021 exam paper that real students sat from AQA. So pause and have a go. I'm going to go to the answer. So 1.5 conservative plate margin at X. So at Y, it wanted you to use figure 2 and your own understanding. So this is really important because it means that you need to refer to the map. It wants you to apply the knowledge that you've learnt from this PowerPoint to the question in the exam. So I've given you an example answer, shown you how I've done that. So I've said at Y there's a destructive plate margin. So I've literally just said what's on the map, and that's kind of applying your knowledge, and that's 1 mark. And again, figure 2 shows the Nazca plate subducting into the mantle. Again, another mark just for application. And then how have I gone about describing how earthquakes and volcanoes happen? Well, it's 4 marks. You don't need too much detail. I've simply given a bare bones explanation. Friction between the plates prevents them from moving, causing pressure to build until the rock fractures, causing an earthquake. 1 mark. We get subduction into the mantle. It melts, resulting in hot magma rising up through the lithosphere, erupting at the surface, forming composite volcanoes. Again, another mark. So as you can see, I've got 2 marks in for earthquakes, 2 marks in about volcanoes. So if you want me to mark your answer, then please do feel free to comment it. But I will say this, you can spend a long time learning how to answer these questions and prepare for them in the exam. At the end of the day, if you're learning geography because you enjoy learning about geography, then you don't want to bother with all the exam technique. So my advice is, if you've done what the question says, then you're basically guaranteed the marks. If you've suggested why earthquakes and volcanic eruptions happen, and you've used figure 2, then you're basically guaranteed the marks. That's kind of as simple as it gets at GCSE. So finally, the key revision points, the stuff that you need to take away from this video and you could be assessed on, what the lithosphere is, how tectonic plates move through ridge, push, slab, pull. So oceanic crust and continental crust, that's quite important. How earthquakes and volcanoes form at the different plate boundaries, that's the main takeaway from this video. As you saw from the exam question, that's the main thing you're likely to be asked from this part of the specification, and obviously knowing where they are as well. So finally, I've attached some further reading if you want to dive deeper and understand to a higher level beyond GCSE how tectonic plates work. There's some helpful links here. So I hope this was helpful in giving you an overview of how earthquakes and volcanoes form. You're going to kind of need this knowledge as we explore the impacts on humans in the next couple of videos.